Alright, hey guys, this is April 13th, Monday for Algebra 1. So we are on page 379. So 379, this is going to be scatter plots. And so a couple definitions before we hop into the lesson. The first definition is what we kind of explored in the previous chapters and stuff is called a univariate data, which is a single variable data about only one characteristic. Previously in the text, a variable was identified as a component of algebraic expression or equation. A bivariate data is two variable. It is possible to examine the relationships between two different characteristics of a single group. For example, one can be to describe the relationship between a person's height and weight, or the relationship between a day's high temperature and the number of people that go to the beach. And so there's a couple definitions. A scatter plot uses the Cartesian plane to graph one of the variables along the horizontal axis and the other along the vertical axis. And so the variable that is used for prediction is called the explanatory variable or independent variable, and the variable that is being predicted is called the response variable or dependent. So explanatory is the independent variable, it's the one that is used for prediction, and the response variable is the one being predicted or dependent variable. So the definitions as we go through to remember. So first, what we're going to do is the scatter plot. So basically all a scatter plot is you plot the data, and it can be it can be all over the place. It can kind of be close together, far apart. It just depends on the data itself. But basically you're just going to plot the points and then kind of look at the data and see what conclusions you can draw. And so, for example, up here, if I gave us x and y, I don't know what they are, I just did it this way. It could be in the text, it can be temperature, it can be, like I said, height and weight, whatever it is. I just went general here with x and y. And so I'm just going to plot these points on my graph first of all. So I'm just going to take the points they give me and plot them. And so I'm going to do, the first one is going to be x is 1 and y is 2. So where x is 1, y is 2. So I'm going to plot a point. The next one is where x is 2, y is 5. So I'm going to go to 5, plot a point. Then the next one is 3, 6. Plot a point. The next one is 4, 8. Plot a point. Next one is 5, 10. Plot a point. Okay, so notice this is going to be different than a line. It doesn't have to be necessarily a line. It's called a scatter plot because these points can be scattered all over the place. And so what happens for this, first off, what I can look at is if I plugged in, say, an x into this, if I wanted to see what the x would be, or what the y would be when the x is a certain number. So for example, if I wanted to know what is the y when x is 4. So what is the y when x is 4? Well, that's going to be the variable that is used for prediction is called the explanatory variable or independent variable, and is graphed along the horizontal axis. And so the explanatory variable is the 4. So it's being what is used to predict something. So the 4, the horizontal axis for the x is the explanatory variable. Now, what is being predicted would be the response variable, the dependent variable, and it is going to be the vertical axis. So it would be the response, the prediction would be up here on the vertical axis. So the vertical axis is the response, and then the horizontal axis is the explanatory. Okay, so that means the prediction when x is 4, the prediction is that y would be up at 8. And so that is how that's going to work. So that's one definition looking at this. Another thing we do is looking at the data. We have a couple of trends that present themselves. So notice this one. Notice how my data is kind of coming up positively. It's all kind of coming up. it's moving up that direction, so that's called a positive association. The definition for a positive association occurs when an increase in the explanatory variable corresponds to an increase in the response variable. So notice this one would be positive, because notice as the x increases, the y is increasing too in general. Now it's not precise, because notice this one jumps up pretty steep, and then these other ones kind of level off a little bit. So it's a scatter plot, so your points are going to be kind of not correspond to each other exactly. But we can say that this is increasing positively, because as it's going horizontal, as these numbers down bottom, the explanatory variables increase down here, then the y, the response variables, are also increasing up there. And so that would be an example of a positive. Okay? A negative association occurs when an increase in the explanatory variable corresponds to a decrease. So that would be an example of a positive one. If I had a graph something like this, and I had it going down something like that, then notice as the x and the y, so notice on this one, as the x is getting bigger, as the x is increasing that way, growing, then notice the y's are decreasing. So this first y will be up here, the second one down here, third one, fourth one, fifth one, and so notice that that trend is coming downward, that the x's are going to increase, you're going bigger on the x one, but the y's are decreasing. So that will be an example of a negative. Okay? And then the last one is no association occurs when there is really no pattern. So no association would be one like this, or maybe we had it something like that. So notice on this one's going to be no association, because as the x is increasing, the y's are just kind of going wherever. They're not really going up steadily, they're not really going down steadily, they're just kind of jumping all over the place. And so that would be no association. It would also be no association if they all stayed at the same line, at the same point. And so if you look on pages 381, they show you an example of, example A there shows you an example of a positive association. Notice how it's kind of like the one I started with. They're kind of growing steadily up, and so as x gets bigger, the y's get bigger as well, and so that is a positive association. Notice number B there. Notice how as x gets bigger, the y's get smaller, and so it's got this downward slope, and so that would be a negative association as it comes down as x gets bigger. And then it gives you an example there on the next page, 382. Notice how C, they're all scattered around, and so there's no association. There's really no pattern there. And then notice D as well. D, it's basically a horizontal line. They're all three there, but that is no association either, because they're all three no matter what. And so one doesn't help predict the other just because they're always three. And so that is essentially the lesson. So the lesson is basically threefold. You have to be able to take the data and plot it. Then you have to be able to tell whether it's a positive association, if it's coming up as the horizontal one's getting bigger. You have to be able to tell whether the explanatory variable horizontal is getting, as it's getting bigger, the y is getting smaller. And then you have to be able to use that information to help predict. And so you have to basically be able to look and say, okay, when x was 2, when I'm looking at this and this was 2, where was the y? Well, in this case it was at 2 and the y was up here at 5. So that's basically the lesson. What I need you to do is do questions 1 through 5. The first one, you're just drawing information out of it. And then 2 through 5, you're having to actually plot it and then tell me whether it's no association, positive association, or negative association. So 1 through 5 on page 383.